Hello there, this is Jason Doris, lead software engineer for Atlas Meditech. This video will guide you through basic use of the Atlas Intelligence software. The home screen gives us two options for launching either Atlas Pathfinder, which lets us plan our surgical path, or Atlas OR, which lets us plan the patient positioning within the operating room. Pathfinder is a typical place to start, so I'll click the button to load Pathfinder. And once it loads, we'll see that there's a view with 4 panels: axial, coronal, sagittal, and a 3D view of the brain. At the bottom left is the surgical plan. This guides us through the process step by step. We see the plans broken up into 4 categories, each with sub-steps to complete. We can jump around to any step by clicking in this window, or we can collapse the window to explore on our own. The first step tells us to move the tumor into position. When this step is started, our notification window on top displays more detailed instructions on how to complete the step. Also, the relevant controls to complete the step are displayed on screen. In this case, the tumor is highlighted. In order to move the tumor into position, we'll need to left-click and drag the tumor from one of the views. A left-click and drag within the window will pan the image. A left-click and drag over the tumor will move the tumor into position. Right-click and drag will zoom the image in or out. Scrolling the mouse wheel will adjust the slice. The same is true for the slider on the right side of the panel. This also repositions the tumor center to the slice that's being viewed. You can also reposition the tumor from within the 3D view using 3D camera controls. Here, I will maximize the 3D view for better visibility by clicking the Maximize button. You can left-click and drag in the 3D view to orbit the camera around a point in 3D space. If I left-click and drag the tumor will be repositioned in 3D space. Middle click and drag will pan the camera. This panning also moves the center position for the rotation that the camera moves around. If I pan the camera over the number 1 marker, I can now left click and drag to spin around the marker. We see from our shortcut menu on the right that pressing the F key will focus the camera on the center of the tumor. Now I can orbit around the tumor. If I right-click and drag the mouse, this lets me zoom in or zoom out. You can also use the scroll wheel to zoom in and out in increments. While we're in the 3D view, we can also edit visibility of anatomical layers using the tab menu on the left. The Anatomy tab gives us options to adjust visibility for each layer. We can turn on X-ray mode from the menu, or by pressing the X key to make the anatomy transparent. We can also disable a feature that automatically makes the hemisphere occupied by the tumor transparent. I can do this also by pressing the Z key. The most important anatomy layers have keyboard shortcuts for toggling visibility. The shortcut keys are visible from the Anatomy tab or from the keyboard shortcut list on the right side of the screen. The Tractography tab lets us visualize fiber tracks. You can also filter them by groups. The Path Drawing tab includes additional visibility options. I can hide the green corridor cone or path marker, or I can hide feedback for the tumor and path overlap with critical structures. UI Scale allows me to adjust the size of the menus and text in the user interface. I can also open and close the tab menu by pressing the space bar or by using the number keys to select the tab I want to access. Now that my visibility settings are customized, I'm going to make sure the tumor is where I like it, and then return from the 3D view back to the 4-panel view. I can do this by clicking the icon on the right panel, or by pressing the O key to switch to the orthographic views. In addition to the 4-way split screen, there are other viewport layout types that I can access from the left tab menu. By clicking one of the icons on the left tab menu, I'm able to choose a different display layout option. This is the 1/3 or the 1/3. And any of these layout options, I can also customize them by clicking and dragging the label into another view to make them switch positions. Here the coronal view is now in the large window and the 3D orbit view is in the smaller window. I'm going to switch back to the 4-panel view. With the tumor position in place, we can refer to the surgical plan to see the next steps in the process. The panel tells us to adjust tumor rotation. The detailed instructions on top tell us the tumor rotation sliders in the tab panel can help us complete this step. We see that the tab panel has the tumor adjustment icon blinking. This is offering us a clue on which icon to select. With this tab open, we see the tumor rotation sliders are highlighted. Dragging the slider will adjust the tumor rotation each axis. It will also complete this step in our surgical plan and move us along to the next step in the process. I'll adjust tumor scale and select a preset shape that resembles my case. The next step tells us to enter the 3D orbit view by maximizing the view or pressing the O key. When in the 3D view, we have access to the recommended approach screen in the lower right. This window can be expanded or collapsed by clicking the title. Whenever the tumor is adjusted, all possible approaches are considered, and the top 3 options are presented to the user. By clicking the name of the approach, we are committing to this option and entering path edit mode. With approach selected, we can now edit the default path by dragging the control points. Since path edit mode is active, we can no longer click and drag the tumor to move it. If we want to refine the tumor position at this stage, we would need to exit path edit mode by pressing the back arrow key. Now we can drag the tumor and get a new recommendation. Our surgical plan tells us we need to edit the path to proceed. To do this, it's helpful to zoom in close to the path. I can left click and drag a control point to move it around. Control points that move the path through a surface are colored green. By default, an option in the recommended approach windows enables snapping to surfaces. In this case, snapping keeps the control point within the sylvian fissure to avoid traversing brain tissue. By disabling the snap setting, I'm free to move the control point wherever I like. Left click and drag moves the control point into position. Right click and drag will adjust the roundness of the path between this control point and its neighbors. In this view, we can see dots along the path that indicate the path is going through a critical structure, in this case the cortical spinal tracts. We'll drag the control point out of the way to avoid this structure. When adjusting the path, it's helpful to view the path from multiple points of view in 3D space. By double-clicking the path marker, the camera moves into position to view the path down the surgical corridor, represented by the green cone. I'll move my control points to avoid any vessels. The next step in my surgical plan is to create an incision drawing on the scalp for where we plan to access the craniotomy. The instructions tell us to access the incision tools from the Incision tab in the left menu. By holding down the left Shift button, we enable the incision drawing tools. A red overlay indicates recommended areas to avoid incisions. With left Shift held down, we can click and drag on the skin to draw our incision. Additional tools let us adjust the drawing size, and we can also undo and redo individual strokes, as well as clear the drawing to start over. We can also cut a surgical window into the skin layer to view underlying anatomy. By dragging the red handle, we can reposition the center of the surgical window. A slider in the Incision tab lets us change the size of the surgical window. Our surgical plan is now telling us to complete the final step, planning the craniotomy. We can access the craniotomy tools by selecting the Craniotomy tab from the left menu. The craniotomy is cut out of a volumetric rendering of the skull, using a custom craniotomy shape. Dragging the yellow handle rotates the cutter around the tumor, repositioning the craniotomy center on the skull. We'll select a preset shape from the menu. Then we can adjust the width, the length. We can also adjust the scale and rotation. The round corners adjustment will give the craniotomy shape a curved edge. The depth and height controls adjust where the cutter starts and ends along the handle. In addition to the cutter shape, we can also perform custom drilling. Like the incision drawing tools, we hold down Shift to enable the drilling tool. You can left click and drag to perform the initial cuts. A second pass will cut deeper into the skull. You can also adjust the drill size for larger or smaller cuts. And you can undo and redo drilling history, as well as clearing to start over. The surgical plan now tells us we've completed all steps and may proceed to the OR. You can enter the OR by pressing the icon on the right menu, by pressing the OR button from the surgical plan, or by pressing the Send to OR button from the approach window. Now that our surgical plan is loaded into Atlas Operating Room, we see a visualization of the patient on the operating room table. Default body position and head rotation for this approach are loaded with reasonable values, but we can make further customizations. The first tab in the tab menu is going to be the patient body position. We have 15 presets here that we can choose between and see how they affect the surgical alignment of the microscope to the surgical corridor in the patient. This approach gets us pretty close. We can see from our picture-in-picture inset view here what the point of view of the microscope would look like. And I'm going to hit the R key to remove the right hemisphere. To get a better alignment with the microscope, I'm going to select the Head Adjust tab. While this tab's selected, we have two rotation handles applied around the center of the patient's head. By left-clicking and dragging, I can move the patient's head either up and down, adjusting the neck extension and flexion, or I can rotate the patient head from left to right. The red handle lets us further adjust the head tilt from left to right. Once I'm happy with patient head positioning, I can further refine the skull clamp placement by selecting the skull clamp tab from the tab menu. By default, we get an overlay that shows us the pin placement zones. This is a colorful representation of the sweatband zone, where the pins can be well aligned to the patient's head. And we see here, if we were to rotate this outside of the green zone and into the red, we start getting a flashing indicator that we do not have a good skull fixation solution. Each handle here is numbered 1 through 4 to indicate the order in which to adjust the handles. The first handle, handle number 1, is going to adjust the rotation of the 2 rocker pins. Where these 2 pins meet the 3rd pin defines the pin plane. And we can see here as I rotate this, we're adjusting the angle of the pin plane. I'm going to adjust mine to match the sweatband region, and then I can turn off my pin zone overlay. The second handle is going to rotate perpendicular to that pin plane, so we're spinning around the axis that we defined in the first step. And as I spin this, you'll see that we have either a bluish green indicator that tells us we have a good fixation, or as I rotate, we get into a yellow or even red triangle that indicates that this is not a good fixation solution. And the reason for this being is that we have 2 angles here to consider. The line here that represents the center point between the single pin and the 2 pins, and we have the center point between the 2 pins. And when these 2 points become misaligned, it has poor indications for skull fixation, and we really want to have a green indicator here. In some cases, you can adjust this by adjusting the translation from anterior to posterior for where the center point of rotation lies. And then the other method is by adjusting the rotation of the second handle. Handles number 3 and 4 deal with the aim direction of the skull clamp. So you can see here I can aim the skull clamp higher or lower using position number 3. And for number 4, if I bring in the surgeon, I can adjust the linkages here to make sure that the lower linkages of the skull clamp are out of the way of the surgeon's knees, giving us more room to operate freely. The same controls for adjusting craniotomy and incision and Pathfinder are also available within the operating room. We have the craniotomy tab, which has the same controls that let us adjust the craniotomy positioning and shape. And we also have the incision tab, which lets us further refine our incision drawings. An additional option lets us change the layout of the operating room by selecting the Room Layout tab from the left-hand menu. With this tab selected, we see a 2D overhead view of the operating room. By hovering and clicking an object, I can reposition any of the equipment within the operating room. I can also create new pieces of equipment from this menu on the right-hand side of the screen. I can click and drag to create new pieces of equipment. I can also bring in additional personnel and change their positioning by clicking and dragging, or I can click on this handle to adjust their rotation and aim direction. When I'm happy with my layout, I can switch from this tab to any other tab to jump back to my 3D view, and the changes are automatically represented in our scene. The 2 inset views can also be toggled on or off by hitting the O key, which removes them or brings them back. Additionally, the layout of these picture-in-picture views can be changed by holding down the Tab key and then click and drag to move them into another position. With the Tab key selected, we can also press the plus key to decrease the size, or the minus key to increase the size of these views. If we decide we want to make further refinements to the surgical plan and the path, we always have the option to return back to Pathfinder. And you can do that by clicking the Pathfinder button up here in the upper right corner of the screen. This is going to take us out of the operating room and bring us back into Atlas Pathfinder. I hope you found this video helpful. Please refer to additional user guide and software documentation for additional instructions. Thank you so much.